Hello everyone, my name is Raina D. Jute and welcome to my Module 8 project. This is a MERN stack app, so that's MongoDB, Express, React, and Node.js, and I'll be going through the main features, showing what's happening on the screen, then switching to the code to explain how it actually works under the hood. I'll also talk through some of the decisions that I made along the way and what makes this project unique and difficult. So without further ado, let's start with authentication, since that's really the foundation of this whole app. So this is the login page. Pretty straightforward on the surface. You have to type in an email, type in a password, and then we submit. But there's actually a lot happening behind the scenes whenever we hit that login button. So let's walk through what happens step by step. So when the user submits this login form, the front end makes a post request to /API/login. It sends an email and password as a JSON in the request body. So let's switch over to the code and show what the backend does with that. So here we are in auth.js. The route handler here does a few things in order. So first, it checks if the MongoDB connection is actually ready. So we check this ready state 1. Then it looks up the user with a case-insensitive email search. That can be found here. One thing I want to point out is notice this select password. By default, Mongoose excludes the password field from queries for security purposes, and here we have to explicitly ask for it because this is the one place that we actually need it. Then it uses this bcrypt compare to check the submitted password against the stored hash password. Bcrypt is deliberately slow, which makes a brute force attack harder. That's a standard security practice. The backend generates a JWT token with this JWT sign. The token includes the user's ID and email, and it expires in 24 hours. The JWT is what the front end will send in the authorization bearer token header for any of the protected API calls. And then if we flip over to session.js, after login, the app also creates a separate MongoDB session via the post API session user ID. That route generates a UUID session token with this random UUID. It stores it in the sessions collection along with the created at and expire at, which is set to 24 hours, and then returns the session token back to the front end. And if we look at our session models, we can see this is where the TTL index comes in. So we set the index expires 0 on the expire at field. This tells MongoDB to automatically delete a session document when its expire at time is reached. So we don't have to write any cleanup code. The database just handles it automatically. And then here in loginpage.jsx, we're back at the front end. After a login succeeds, the JWT token goes into session storage, and then we call the session create endpoint to get the session token. Once we get that session token back, we store it in a session token cookie. So if we go back to the login page and we hit login, you'll see the success toast notification fire login successful, and then we redirect to our home page. Now if I were to enter in invalid credentials, we are redirected to the unauthorized page, and then we see that invalid credentials toast pop up. One more thing on authentication. So every protected page in this app is wrapped in a protected route component. So every time you load a protected route, it reads the session token from the cookie and then validates it against the backend before rendering the page. If the token is missing or expired, it'll redirect you straight to the login page. I'll show you that component briefly. So we're taking a look at protectedroute.jsx. And you can see that there are 3 states here. There's checking, there is invalid, and then there's valid. On mount, it grabs the cookie and calls the session validation request through session service, which is seen right here. And this is the exact call. So we make a GET request to this validate token API. The token is then sent as a query parameter. And then on the back end in this validate token.js, this endpoint queries MongoDB to ensure that the session exists and hasn't expired. And if it's valid, it returns a normalized user object, which is the email, the first name, and the last name. And if it's invalid, then it returns this invalid or expired response. So now let's move on to agent management. From the home page, I click the agent management card right here, and this is the agents table. So it's pulling all the agents from the database and displaying them in a sorted filterable table. So we can sort by first name, and then we can also sort by region. So let's start with how the data gets here. So when this page loads, a use effect hook fires and makes a GET request to API/record with the JWT token in the authorization header. The backend queries the agent collection and returns all the agents. That data goes into component state via use state, and then the table renders. The region filters that you see right here, north, south, east, and west, that's sorted using a predefined priority array. So it's not alphabetical and it always stays in that specific order. So let's take a look at that. So here is the region order array. So when I sort the drop-down options, I use the index of, which is seen right here, to find each region's position in this array and compare by that index. Also, there's a normalization function that runs on every region to make sure the capitalization is consistent. And that can be found here. Things like all lowercase north or all uppercase north get standardized by this normalize. Any value that doesn't match the allowed list shows up as invalid in the table. So now let's switch back here and create an agent. I'll go ahead and fill in the form. So a few things are happening with the validation here. Client side, I check that all of the required fields are filled in, so all of the fields that have this little red asterisk. I make sure that the email matches the regex pattern and that the fee is greater than 0, and then let's submit and see what happens. So a confirmation modal appears before anything gets sent to the server. I implemented this for all destructive or important operations, create, update, and delete. The idea is just to give the user a moment to confirm before the action is committed. If I click no, nothing happens and the form stays filled in. And if I click yes, the post request fires. And then of course we can see this success toast pops up as well, just another user feedback that helps them to know exactly what's happening. Now looking back at the code, here we can see a two-step flow. So when the form submits, instead of immediately making the API call, it sets a pending agent data state with form data. The modal's show prop is tied to whether pending agent data exists. When the user clicks yes, handle confirm create runs, that's where the actual post request to API/record happens. On success, we show a success toast and navigate back to the agent list. And then, of course, we can see that new agent exists right here in our table. You'll notice that after any mutation, create, update, or delete, I refetch the whole agent list from the server instead of just updating the local state. I made that choice to keep things simple and to make sure the UI always reflects what's happening in the database. And if we try to delete, it's that same pattern. That confirmation modal appears with the agent's name in the message. I thought that was important so you know exactly who you're deleting. And let's take a look at that quickly in the code as well. So the modal message is constructed dynamically from the agent object. So when the delete button fires, it stores the whole agent object in agent to delete. When the delete button fires, it stores the whole agent object in agent to delete state, not just the ID. That's so I can use the agent's name in the modal message. When the user confirms, we make the delete request to API/record with the agent ID, and on success, we filter that agent out of the local state array and show a success toast. And then you can see here we refetch that agent list again just to make sure that what we're seeing is the most updated version. And of course, when we hit yes, we can see that that agent is deleted from our table. Now let's take a look at the transactions table. This page shows the last 10 transactions in the database and has a form to submit new ones. So the table shows the 3 columns: the date that the transaction was made, the amount of the transaction, and the agent name. These are sorted by most recent first. So the backend does a sort date -1, and again that -1 just means that we are filtering in descending order, which means that the most recent will be shown first. So let's walk through submitting a transaction. So first we select an agent from this dropdown, and this dropdown is populated by fetching the full agent list from that same API record endpoint we used in the agent management. So each option shows the agent's name and their MongoDB ID. So let's select Reina, and this amount field only accepts positive numbers. There is a regex validation on both the front end and the back end for this. It allows up to 2 decimal places and then nothing else. So if I try to enter a negative number, it gives us that message saying that the amount is invalid, and if I try to enter any letters, same thing, we needed a valid amount. And then again, once we hit submit, that confirmation modal shows up again. The reason I put a modal here is that transactions aren't deletable in the system, so I want users to be really intentional about what they're submitting. Of course, we hit yes, and we can see it populate at the top of the table and that success toast. And then we are in our transaction.js right now, so here's where it gets a little bit more interesting on the back end. When that post request comes in, as we can see right here, we first validate the amount and the agent ID. Then, and this is something that I learned from this project, the transaction creation uses a MongoDB session to handle two operations atomically. And as you can see, that start session is right here. We create the transaction record. We also increment the agent sales count using this $inc. Using a session means that if either of these operations fail, then both of them get rolled back. So we never end up with a transaction in the database without the agent's count being updated, or vice versa. So now let's move on to the extra miles, which is the report page. So this feature shows two charts, a bar chart total of transactions per agent and a line chart showing the daily transaction totals over the last 14 days. These are built with chart.js and the React chart.js-2 wrapper. So let me switch to the backend and show the more interesting part, which is the aggregation pipeline. So this endpoint does two separate MongoDB aggregations. For the bar chart, it groups all the transactions by the agent ID, sums up the amount, and then does a lookup to join all of the agents with the collection. And that lookup is right here at the top. That all happens in MongoDB, so I'm not fetching all transactions to the server and doing the math in Node. The database is what is doing the heavy lifting. For the line chart, I filter transactions from the last 14 days. So we do this get date minus 14, and then we group them by the date. Here's something I had to figure out. MongoDB only returns days that have transactions. So if there were no transactions on Tuesday, Tuesday just isn't in the results. On the front end, I generate a complete 14-day range and fill in zeros for any date that's missing from the API response. That's why the line chart always shows a continuous 14-day window. And the charts render responsively. They resize with the window, the bar chart is alphabetically sorted by name, and the line chart goes chronologically from left to right. Let's walk quickly through the notification system and validation. So we'll start by trying to submit an invalid transaction form. If I try to submit the form without filling it in, you'll see the validation errors appearing in line below the field. This is client-side validation. For API level feedback, we use toast notifications throughout the app. So there's a toast context that wraps the whole application. Any component can call show toast message, type, and the type is success or error. And the toast appears in the top right corner and dismisses after 5 seconds. So if I were to do a successful one, we can see that toast notification showing up. And in VS Code, that is under the toast context.jsx. The context holds an array of active toasts. Show toast pushes a new one into that array. There's a check to prevent duplicated toasts from appearing at the same time, which is this duplicate toast equals current toast. When the timer fires, it filters that toast out of the array. Fairly simple, but it works everywhere in the app consistently. And just to wrap up, we can do a quick look at how the whole thing is structured. So we've got a client folder up at the top, which is the React front end. And we have a server folder, which is the Express backend. They communicate over HTTP. So the front end makes fetch requests, the server responds with JSON. On the front end, we use React hooks for all state management, use state for component data, use effect for API calls on mount. There's no Redux or anything like that. For an app this size, prop drilling and context is enough. And then on the back end, every protected route goes through a JWT authentication middleware that validates the token before any logic runs. The session system adds a second layer on top. The session cookie validates against the database on every page load. So that is the full walkthrough. Authentication with JWT and cookie-based sessions, agent, CRUD with confirmation modals and toast notifications, transactions with atomic database operations, reports with MongoDB aggregation pipelines, and a validation system that covers both client and server sides. So that is the gist of this project for Module 8, Week 8. There's a lot of things about this project that I would like to improve my understanding on, like the session validation response format, but I learned a lot about a full stack system and how it all fits together. Thank you for watching, and I will see you on the next one.